Well, hello friends. Welcome back to browser hacking. Today we are going to do arrays in JavaScript. So we'll start with a little test program because we don't have anything like arrays yet. So I guess we'll just put it here. Array.js. Okay. So how about something like A is an array of 1, 2, 3. And maybe we will do something like 4 I console log AI. Okay, so that's pretty good, right? So let's try running that on the host here, because I have some JS thing. Comes with Ubuntu. I guess it's V8 or something. And it does what we expect. So now let's make our JS engine do the same. So we're gonna have to parse array expressions and then implement array lookups and a whole bunch of things, and create array objects. Okay, so we can't parse this thing at all. Okay, let's see. Let's bring up one of those AST explorers. And let me just copy paste this thing over here. Okay, and which one do I normally use? Esprima. Okay, so we can see that this here is a variable declaration with an identifier here, and then an array expression, and then an array expression has elements, and it's just a sequence of comma-separated expressions. So let's parse that. Well, I guess first we'll add an AST node for it. So this would be a bit like object expression, except different, but we can start with that as a template. So array expression. Okay. But the difference is that, I mean, object expression is not fully implemented because it doesn't have members. But here we're going to need a non-null ref footer vector of expressions, and we'll call it elements, and we can expose that. Wait a minute, I forgot to name it. Elements. Oopsie. Elements. Okay, and we should probably take one of these when we're initializing it. Non-null refer vector to expression elements. Okay. That's a pretty good node, I think. So let's parse that. So we go into JS parser. And we'll have to look at the way that we parse expressions. So first we check if match expression would detect a bracket open. Yes, it will. Okay, so if we match an expression, that means that we will call parse expression in some places. So parse expression is divided into the primary and secondary expression, and in the case of, in this case here, this array expression is just going to become a primary expression that starts with a token type bracket open. And then we'll say parse array expression. Okay. And I guess we can start with that, actually. So let's see how we parse object expression. We can just start with that. Okay. Parse actual object expression. I agree. Okay, so array expression starts with bracket, ends with bracket, and I'm gonna collect a bunch of elements, and the elements will be a non-null referer vector to expression. Okay. Oh, and we need to actually declare this. Okay, so we have consumed the bracket open, and then there's going to be a list of expressions. So while match expression, elements append parse expression, minimum precedence 0, and then if match token type comma, no, if not comma, then we break. Otherwise we'll loop around again. Wait, am I getting this right? I feel like I've done this before somewhere. Match token. Oh, yeah. This is the same as the call expression. So we have to consume the comma, obviously. Token type comma. All right. Good. So I think that should at least create the AST node, and then we can we'll have to implement the functions in the AST. So value array expression execute, and actually we should have looked at object expression for this one, because actually not terribly fascinating. Okay, so we want to make a new object that's an array object. So we'll say allocate an array, and oh wait, what's happening to my hotkeys? Okay, so make an array, but we want to actually also append all of the things to it. So element in m elements, array append element execute in the interpreter, something like that. I think that makes sense. Okay, so then we'll just need to actually come up with the array object. And I guess an array is an object, right? So let's just go with that. Namespace with JS runtime object. All right, so an array is a public object, and we'll have a constructor and a virtual destructor, and we'll need some helpers and things. Let's make it final for now. We definitely want to override class names so that we can say that we are an array. And we're also going to want to override visit children, because this thing is going to be full of garbage collected elements potentially. So we got to keep track of those. And I know that arrays can be like sparse and have holes and stuff, but we're just going to skip over all of that stuff right now and use a standard vector as the underlying storage. So we'll just say vector value elements, and I think that's okay. Then we can just expose this like this for simplicity right now. Now, maybe we'll also have like, well, I guess an I32 length, elements size, we'll static cast that. Okay, and I wanted append, right? So append value. That's a good start. Okay, so let's flesh out the CPP file. We can maximize this. JS, runtime, array. Okay, so starting with the baby stuff, just the constructor and destructor. And then let's do the garbage collector visitor thingy. Visit my children. So this will just be iterating across the elements and saying hello to each one. So basically visitor, visit, element. And of course we need to also call it to base. So there we go. Now this will ensure that any value that's pointed to by an array will survive garbage collection if the array survives garbage collection. Okay. Now we need to implement append, basically. Append value. And for now, this is dead simple. We'll just say elements append value. And I think we're good. Obviously, these things are going to get more complicated over time, but for now they stay simple. So we can actually add a native property here. So put native property length, and the getter is going to be this object, or let's just do it this way for now. And it's going to return length, I guess. We have to say value like that, yeah. And then the setter is going to do nothing, I think. I'm not sure if this is even settable, so we should do something here, but I'm not sure exactly right now what it is. We'll figure that out later. Okay, so we need act function, and I see that we also need some copyright headers. Let's just put those in right away. And same thing in array.h. Very good. Okay, so I think those classes are pretty good. Maybe we'll skip over this part for now, and we'll just say, yeah. Because now, though, the tricky part becomes when you do like when you do a property lookup on an object, if that object is an array, then we need to know that we have to go look in this elements thingy here rather than just going straight to the property table in the object. So we're going to need to be a little bit smarter here, and let's just add some isArray thingy. And we will put that on, I guess we can put it on object. And then in object get, if we are doing a get, let's see, how does this work again? Okay, let's get back to this part. I'm just gonna let that stew in my head for a moment. I'll remember how it works by the time we get back there. So let's see, now we were parsing, so JS parser, parse array expression, append the elements, pass to this constructor, and then when we execute him, we create an array, So we need to include the array class. Array. All right, so there we go. That's pretty good. And then we can simply return it. I wonder if this will just work. Let's see what happens if we do like console log a. Oh, and then I should have also built. Oh, forgot the dump expression, or the dump of the array expression. Fair enough. Ast node dump indent for auto elements. Intent plus 1. Yeah. JS array. Okay, so I think we're good here. We assign an array expression to A. The array expression has these elements, and we indeed, when we console log it, we just print out object array. And I think that's what it's supposed to do. Would this thing do the same? Not quite, because it's smart enough to console log arrays properly, but that's another thing. Regardless, I think we're in a good place here, so maybe we should be nice to ourselves and just commit at this point. So because we're going to keep pushing forward anyway, so git commit the JS parse array expression and start implementing array objects. Property lookup. Note that property lookup is not functional yet. Okay. So let's re-enable the property lookup here. So what would happen now if we just ran this the way that it is? Oh, it's not even going to parse, right? And what did we have here? So we have a call expression inside of this for loop, blah, blah, blah. Call expression, call a member expression, where the object of the member expression is the console identifier, the property is log. Oh, right, but then we're inside of, wait, what am I looking for? Arguments, member expression. This is the member expression I'll look at. Right, so this member expression is computed, which means that it's a bracket-based lookup. So we got to implement computed member expressions. So let's see, member expression, we'll just add it as a flag here. So computed, maybe we can even say like type, or computed. It's okay with bool. I was gonna do an enum, but like, it's not the most important thing in the world. Bool and computed, false. Maybe we should do it that way too. Okay, bool computed const. I'm not typing very properly here. Okay. There we go. Okay, so let's parse these. So that's just like if you did like, let's see, if you do I like this, right, then you get a computed member expression. And if you do a.i, you get a not computed member expression. So these are basically the same in the AST, except the computed flag is different. So it's computed, not computed. And of course the difference, the reason it's called computed is because you have to actually compute the expression within the brackets before you know the subscript. So we have to compute the property expression in execute. And let's see, how does this work now? So right now we check if the property is an identifier. If so, we grab the property name from it like that, otherwise we are not reached. So I think maybe the easiest thing to do is to make a helper function that maybe does something like computed property name, like that, and then we can separate this out. Interpreter, and then we'll say if the member expression is not computed, then we know that the property is an identifier. So in that case, we can just return static cast const identifier and property string. Yes. Otherwise, we have to execute this in the interpreter and stringify the result. Okay, and then this here becomes easier because we can just collapse this and say computed property name in the interpreter. Okay. I feel like that's what we need. Oh, no, I forgot to parse. Shit, okay. So it's an member expression, right? Parse member expression. That's not a thing. Okay, where do we generate these? Token type period. So what is this? Secondary expression. Okay, so let's see it. Just verify that we match secondary expression. We need bracket open. We don't have it, so I guess we'll just put him next to period here. Bracket open. All right, and then parse secondary expression needs to where's the period? There. It just needs to grab the bracket open and I guess we should consume it here. So consume token type bracket open, and we'll parse an expression here. So parse expression. No, wait, hold on. We want to create a new AST node. Expression is create AST node member expression. Same as up here, right? Except really the only difference is that instead of skipping over a period, we are taking whatever is within the brackets. Oh, and we have to actually open braces here so that we can do this. And then we'll return the expression. Oh, and we have to also say it's computed. Yeah, all right, so that's pretty good. Let's try it out. Oh wait, what am I doing? I wanted array. That was not quite doing what I was expecting. So did we parse this correctly? Member expression, AI. I guess that's accurate, or I'm confused. Also, it's confusing that these, we should dump something more interesting about these. Let's see, how does this work again? Right. Member expression dump. Where is the dump? Here it is. All right. So in addition to the class name, we can also dump that computed is, I guess, is computed true or false. So make it a bit easier to understand what we're looking at in the AST dump. So let's just do that again. So okay, so we have console.log, computed false, makes sense, and then a bracket I, which is computed true. But we are still not getting the expected output. I wonder what's up with that. So what if we just disable this for a moment, and then we say console.log a of 0. Oh wait, I just realized that I didn't implement property lookup. So that's not going to work right, of course. So I was expecting to have figured this out by the time I got back to this. So I guess that when we do a get, what we normally do is we just traverse up the prototype chain looking for the first object in the prototype chain that has this property with the name that we're looking for. But I think if we find an array here somewhere, so let's see. Value is object properties get. So if object is array, static cast array, I guess. So I think we're going to hard code a little bit of array related stuff in object get, because we're not going to do this for every object type, obviously, but for arrays, we're probably going to need to do some special stuff. So let's see. Oh, we need to figure out if we're looking up a number. So right now we always get the subscripts as strings. So even if you pass in like 0, you're still going to get 0 as a string here, because that's just how the engine is set up right now. So we'll have to convert the property name to a number and see if that works. Say index is property name to int, okay. If okay, then if index is less than, no, wait, let's get ourselves as an array first here. So auto array. Okay, and then if index is greater than or equal to 0 and index is less than array length, then return array elements at index. Ploof. And if it's outside of the bounds, we'll just keep going up the prototype chain. This is kind of weird, but and definitely not super correct, but maybe it will do the trick for now, and then we can come in and fill in more correct behavior later. Let's see, so array. All right, there we have it. So now when we try to get a property from an object, we special case for arrays like that. I think that's probably okay. You could generalize this. I mean, we could make it virtual, actually, but I don't know. I don't mind this so much right now. Maybe we'll generalize it later. Okay, so we should probably also have something for when you set something in an array. So print it out, but not before we change the middle one to a 5. So 153 totally works here. This is definitely not going to work in our engine. Yeah. So what happens here is we create, do we make an assignment expression? Yeah, here. So an assignment expression where we're assigning a bracket 1 and assigning 5 to it, but the assignment expression doesn't understand what to do with this. So assignment expression, I think it's just, it assumes, I guess, that you're doing a dot lookup. Let's see. Or actually, no, it is a little bit smarter than I remembered. Okay, so this is the identifier scenario. If we have an identifier on the left-hand side, or if we have a member expression on the left-hand side. If it's a member expression on the left-hand side, then we don't want to just, we're just blindly casting the member expression left-hand side to an identifier, even though in our case, that's not what's there. It's say something else, right? Or wait, am I even forgetting what was on the left-hand side? This is member expression on the left-hand side is an identifier. Property name. Oh, yeah, right. It's the property. So it's the right-hand side of the member expression. So this thing, we are casting this thing to an identifier, which is totally wrong. And it's not an identifier. So this code is very buggy. But we made that nice helper. So now we can just call that. And we can just say, I guess, wait, we can just get rid of this cast. And instead, we can just ask the member expression, what was it called? Computed property name? I think that's it. Because now member expression takes care of figuring out if this is a computed or not computed subscript. No, that did not work. Okay, why not? Probably because we didn't implement object put. Right, we only did get, we didn't do put. So we got to do the same special case here for array. So if object is array, then it's a lot of the same stuff. Except it's going to be a mutable one, and then I guess technically we should allow you to expand the array by setting random indexes. So let's see. If index is greater than 0 and blah blah blah. Okay, so we'll do something like if index is greater than 0, then okay, and if the index is less than, no, if it's greater than or equal to the length, then we'll grow the array. Resize. Array resize to index +1 so that we can assign it. And then after that, we can just set the value. And these guys are going to need to have some writable variants, so like that. I can just do it this way for now. Okay. Cool. No empty JS value thingy. Oh. JS value cannot be default constructed. Well, we should probably allow that and just make an undefined by default. We can live with that. So value and type undefined. All right. So then when you're like growing an array, we'll just have undefined in all of the automatically added spaces. Cool. There we have it. That's pretty nice. Okay. So the AST was looking sane. Yes. Okay, great. So let's see. Let's do this one separately, the value one. Libjs allow default constructing a JS value. Undefined. And now we are just supporting member expressions, computed member expressions, and assigning to them and reading from them. And then we're also implementing object get and object put for arrays. And I don't love this code, but I don't want to come up with a new abstraction for this right now. I'm just gonna let that one simmer for a while, and I'll come back to it some other time. But let's see. Let's do everything except that one, maybe. STH and parser. Okay. Okay, so libjs parse computed member expressions. Member expression comes in two flavors. Computed A of B, non-computed A dot B. We'll do something like that. Yeah, we can now parse both of the types. Strong commit message. All right, and then let's just commit the rest. So JS support get reading, writing elements in a JS array via object get put in an array via object get put. Okay, so not completely thrilled about object get and object put having special, no, doing special case stuff for arrays, and we should probably come up with a better abstraction for it. But at least it works for now, which is really nice. Let's do one of those again. All right. And maybe we'll add array prototype and maybe have push. That'd be cool if we could push. So in addition to this, we'll also, we should check the length property actually. So a.length. And let's see that still works. I never tested length. Array, that works, okay. And let's say a.push 7. Okay, so that works here. So we'll have to declare the array prototype class. I feel like it's really good to start getting all of these basic building block classes into the system, and so we can start fleshing them out, because you just have to get them up and going a little bit, and then more people can come in and fill in missing functionality and stuff. It's been really nice seeing random pull requests coming in, people fixing little things here and there, and adding a little functionality to something. It's very cool. I love this organic growth. Apparently I can't type prototype while I'm talking, type property every time. Okay, so array prototype. Let's see, maybe we can take string prototype and start with that. So array proto. Array prototype. Yeah. And we can take string prototype for the CPP as well, just as a starting off point. And let's do push, right? Okay, and that, and we'll grab array and get rid of some stuff. And let's see. So what do we want to happen here? So we have this object, and we have arguments, and the argument, we only care about one argument really. So if arguments is empty, we're just going to return undefined. I think maybe we were supposed to throw or something in this case, but whatever, we'll get back to that. And our argument is an arbitrary value, and for now we're just going to assert that this is an array. This is not guaranteed. This is another thing we have to come back to eventually, but right now we're being a little bit lazy with this type of stuff. That's why I'm just putting all these assertions all over the place. These are things we have to come back to once we learn more about how this exactly is supposed to work, because it's not crystal clear to me, to be honest. So arguments 0, that's the thing that we want to push to the array. So we can just say static cast array, this object, append, like that. Maybe we should call that function push, actually. Would have been a better name. Push. Push. All right. And then all we need to do now is just make sure that we set the prototype of new array objects to be the interpreter's array prototype. And we're going to change around how prototype acquisition works, I think, later once we do constructors, but right now this is how we get them. So we get them from the interpreter, and he just has a set of global prototypes. So we'll add this one right here, array prototype. Array prototype. And we need to make sure that we protect it from garbage collection. So roots set m array prototype. And we need to also make sure we construct it in the interpreter constructor, array prototype. Oh, right, I renamed append to push. Control reaches end of non-void function. I guess we have to return something here, right? So we'll just return undefined for now. Maybe we can look it up actually. Array prototype push. What do you return? The new length property of the object. Well, I did not know that. So we can make it do that. Oh, look, it works. Very cool. And the garbage collector did not sweep anything, so that's fine. We should return the length of it, right? So I guess for now we can just do it this way. I know that this is not the super correct way of doing this, because array prototype push is supposed to work on anything, I think, that has a length getter or a length property on it. But right now we're just going to fall apart if it's not actually in one of our own array objects. This kind of generic stuff, something we have to come back to later. Okay, so I guess we can verify that it actually becomes 4. Array push result. Push result. Okay, so it should give us a 4. Let's see if our implementation does that. And it does. Beautiful. Okay, so I think we have some pretty good stuff here. Let's make sure that we commit all of this gunk as well. Commit a JS. Add array. Array prototype. Implement array prototype push. This function is ultimately supposed to be generic and allow any this that has a length property. But for now, it only works on native array, or on our own array object type. Anyway, that's pretty awesome. Pretty awesome. So, just some very very nice work on the JS engine here, I would say. Let's bring up that array thingy. Notice the syntax highlighting in the editor, something that Orico made. It looks so good if you switch to dark mode. I love it. And it works. And oh, let me show you something else I did. Just a tiny little thing I did today. That you can do this. You can make it executable. And then if you do this, then you can actually run it like that, like it's a shell script. Just imagine the amazing things we can do with this. Very, very cool. I didn't really do this for any particular reason other than realizing that it was super easy to just make this possible, and you can now make shell scripts in JavaScript. Anyway, I think this is going to be it for today's video. So I think we accomplished quite a lot. And thank you for watching, for sure. I hope you saw something interesting. I really, really enjoy working on this, as you probably realized by now. So thank you everyone for hanging out, and I'll see you next time.